places that you start looking, right, for resources: CPU, disk, memory, network. This one here I grabbed Page Life Expectancy. This one is an indication of memory. If you look out on the web, there are thousands of white papers that represent and misrepresent what this actually does. Do you want to speak to it first?
Well, by default, SQL Server will keep a 8K page of data in the data cache. By default, it tries to hit the number 600, which is 5 minutes. However, as our databases have grown in size, a value of 600, let's say if you were to write an alarm just to watch that, for most databases on a modern piece of hardware, your number should be much higher than that because you have enough RAM to store quite a lot of your database in cache for much faster access. And so your note there is spot on.
Yeah, let's say you hope you have enough memory to store a lot of your database, right? If you're running a terabyte of data on a SQL Server standard, you're not going to get nearly as much access to nearly as much memory as you might hope.
Absolutely. And on top of that, as we had discussed a minute ago, if you're also running reporting services or analysis services or any other non-SQL Server services on your hardware, then they will consume a couple gigabytes each typically. And so you lose memory to other processes.
Yeah, and for those of you who are not database geeks like Kevin and I, as fast as your storage is, it doesn't really matter about the page life expectancy because all the operations have to happen in memory. We don't perform any operations on the disk. We bring it off the disk, bring it in memory, all the operations happen there, whether it's read, write, anything else. So as we're looking at this particular server, we're looking at it across time. We've got about a week here, and it's always down in the not almost always down below with the 280 range. I just picked one of those numbers at random to bring it up. And for this particular group, they're experiencing all kinds of issues. And the first place I looked was here. And I said, well, the first problem you're running into is that your memory's starved. And they said, what do you mean memory starved? And I walked through all this. And I said, if you look at the white papers are going to say that you want a PLE, page life expectancy, above 600. But in real life, I like to see it above 10,000. That's a personal preference, and I'm sure there are other people as experienced as I that might have different preferences. Do you have a number that you like to pick where you're going to tell them it's problematic?
No, I do have a number. It varies, though. The correct answer to all technology questions is it depends, right? And so it depends on how much overall memory you have for SQL Server as a ratio compared to the size of the database. So it could be 1,000, it could be 4,000, it could be 10,000. So it's for me, it's kind of a moving number according to how much RAM, how big is the database. But one thing I would like to throw out there as well, Jeff, is that many generalists, I find, if you go to Stack Overflow or Reddit or any place where you can ask a question, the Microsoft SQL Server forums, you'll see a lot of people saying, oh, my SQL Server is so weird and inefficient because every time I open Task Manager, I see that it's consuming every available bit of memory. And long story short, if you're using Task Manager to try and troubleshoot SQL Server, you're doing it wrong.
Yeah,
and because it doesn't understand. Yeah. So I'm sure you've seen that as well with your customers.
Yeah, Task Manager, it just doesn't really matter because SQL is going to grab as much memory as it can and it's going to keep it. What we're looking at here really is, are the pages that we're referencing frequently staying in memory or getting pushed out? If they're getting pushed out because the PLE is low, you've got a lot of extra I/O going on, and if it's staying up in there, you're good. And as you mentioned, it's how much data are you using? I mean, you use as a reference point size of the database, and I'm going to modify that slightly because it's the amount of data you're using. So in a lot of organizations, you got 20 years worth of historical data in your database. What are you using the last year or two or three? But that doesn't necessarily help because you've got these big indexes now, and you want to keep as much of those index structures up in memory as you can as well.
Mhm.
Disk queue length. So let's talk about what disk queue length means. The disk queue length is the number of I/O operations that are sitting at the controller level waiting for completion. So I want a page, I look in cache, it's not there. I push this off to an I/O request. Now that's expensive because not only are you going for the physical I/O, which is about as expensive as you can get, you're also swapping your process out while waiting for that I/O to complete.